Okay, guys, so this is lesson 2.6 for algebra, and let's get started. So go ahead and put your name. In this lesson, we're going to learn about ratios, rates, and conversions. And let's go. So comparing using unit rates. So you're shopping for t-shirts. Which store offers the best deal? So store A is giving they're offering 2 shirts for $25. Store B says that you could pay $45 and you would get 4 shirts. And store C says that you could pay $30 and get 3 shirts. So in order to compare these 3 stores, what we need to come up with is what's called a unit rate. And a unit rate is just basically a rate with a denominator of 1 unit. Okay, so in this case, we want to find the price per shirt. So price per shirt. Okay, so that in this case would be $25 for 2 shirts. Okay, but notice how we have 2 shirts in the denominator. In order to get it down to 1 shirt, we have to divide both the top and the bottom by 2. Okay, because then that will make it 25 divided by 2 over 2 divided by 2 shirts. This will give us $12.50 per shirt. And that's 1 shirt. Okay? So $12.50 for 1 shirt. We're going to do the same thing for store B. So for store B, we've got $45 for 4 shirts. Okay, so we have to divide the top and the bottom by 4. Why are we doing this? Because we want to find out what each of them costs per shirt. Okay, so what is store A offering as their price per shirt? What is store B offering as their price per shirt? And what is store C offering as their price per shirt? That's how we can compare all of them. So once we divide by 4, this denominator is going to become per shirt, 1 shirt, and the top is just going to be $45 divided by 4. So what we're going to get is $11.25 on the top per shirt. And yes, you should have used a calculator to find that out, okay? All right, and then the last one, so store C. We've got $30 for 3 shirts. If we divide by 3 to both the top and the bottom, we are going to get that it is $10 per shirt. So in that case, this would be our answer. It is the cheapest dollar amount per shirt. So store C is offering the best deal. And the next slide asks us, if store B lowered its price to $42 for 4 shirts, does the solution to problem 1 change at all? Well, let's find out. So store B. They are now offering $42 for 4 shirts. In order to figure this out, we need to divide both the top and the bottom by 4. This will give us, on the top, 10.50, so $10.50, and on the bottom per shirt. And that is still more expensive, so no, it will not change the solution. Remember, store C still has the best deal. Okay? All right, next problem. So conversion factors, converting into a different unit. Conversion factors are always equal to 1. The reason they're always equal to 1 is because they do not actually change the value. Do not change the value. Okay? Just units. All right? It does not change the actual value. We're just changing the units. So if we start with 330 minutes, we want to find out how much that is in hours. So we're converting from minutes to hours. So 330 minutes. What we're going to multiply by is going to be a fraction. And in the denominator, we're going to have minutes. And in the numerator, we're going to have hours. And the reason I set it up like this is because our minutes are going to cancel. Because we have some in the denominator, and we have one in the denominator and one in the numerator. Now, a minute is not equivalent to an hour, so we have to find out something that is equivalent. So in 1 hour, we have 60 minutes, okay? 1 hour is equal to 60 minutes. Okay, so that's how we're going to set up our conversion factor, and all we do is just multiply it. So now we're going to get 330, the minutes canceled, so times 1 hour over 60. And this will give us 330 divided by 60. I'm just going to plug that into a calculator. And that will give us 5.5 hours. Okay. All right, let's try the next one. So we've got 15 kilograms. We want to change that into grams. So 15 kilograms. Remember, when we're multiplying, we want to multiply by a conversion factor. So we're going to multiply by a fraction. Kilograms is going to be in the denominator, and grams is going to be in the numerator. Why? Because we want to change it into grams, and we want kilograms to cancel out. We want to get rid of kilograms. But it's not 1 kilogram to 1 gram. It's 1 kilogram is equivalent to 1,000 grams. Okay? So when we multiply this out, it's going to become 15 times 1,000 grams all over 1. Okay? And then this becomes 15,000 grams. Because anything divided by 1 is just itself. All right. Conversion factor, so converting into a different unit. So if we have feet, we want to go to inches, but we've got 5 feet and 3 inches. Let's figure this one out. So in order to go from feet to inches, we have to rewrite this as 5 feet plus 3 inches. Make sure you're not converting the inches again because the inches are already converted. So it should just be 5 feet plus 3 inches, but we need to convert that feet into inches. How we do that is we just bring it down here. And we're going to write 5 feet, and we're going to multiply it by feet and inches on the top because we want it to turn into inches. We want to get rid of the feet. And 1 foot is equivalent to 12 inches. So this is going to become 5 times 12 inches on the top, all over 1, which is just 60 inches. Once we add that back into our original problem, we have 60 inches now for 5 feet plus 3 inches, which is what we had before, and that will give us 63 inches. Okay, conversion factor, switching between different measures. So in this case, we're going to start with feet, and we're not going to convert it into inches or anything. We're going to convert it into meters, which is a completely different unit. So a building is 1,450 feet tall. How many meters tall is the building? Use the fact that 1 meter is approximately 3.28 feet. Now, Whenever it gives you something like this, that's considered a conversion factor. So all we're going to do is write it in the way that we want to. So we're going to write it as 1 meter over 3.28 feet. Okay? The reason we write it like this is so that we can use it to convert the 1450 into meters. All right? So let's take 1450 and we're going to multiply by, I forgot the units. That's 1450 feet, and we are going to multiply by 1 meter over 3.28 feet. What happens with these feet? They cancel, and what we're left with is 1450 meters per divided by 3.28, which will give us, when you plug it into a calculator, it gives you approximately 442 meters. Approximately. Okay. All right, conversion factors using two conversion factors. So sometimes we have to convert 2 units into different measures using 2 conversion factors. Okay. So a student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round your answer to the nearest tenth. So let's go ahead and write 50 yards in 5.8 seconds. Okay, and now we want to convert that into miles per hour. Well, we know that yards has to somehow get converted into miles, and seconds has to somehow get converted into hours. So what we're going to do is we are going to multiply first by 1 conversion factor, which is going to get rid of yards. So we want to cancel out yards in the bottom, and we want to change that into miles. Then we're going to multiply by a second conversion factor that's going to get rid of seconds. But remember, seconds is now in the numerator. The reason is because seconds started in the denominator. Okay, do you see that? And now we need to get rid of seconds by putting it in the numerator, and we want to change that denominator into hours. So we put it in the denominator. Okay, now watch what happens. We've got yards in the top, yards in the bottom, and we've got seconds in the bottom, seconds on the top. Okay, now all we have to do is convert these. Okay, so in miles per yard, there is for every 1 mile, there is 1760 yards. Let me just double check that. That is correct. And for seconds in an hour, there are 3,600 seconds per 1 hour. Okay, so now we've got our proportion. Let's just multiply straight across. This becomes 50 times 1 times 3,600, and on the top we're left with miles over 5.8 times 1760 times 1, and on the bottom we're left with hours. This is going to give us 50 times 3,600 is 180,000, and on the bottom we're going to get 5.8 times 1760, 10,208, and that's miles per hour. And this simplifies to, once you use a calculator to divide, 180,000 divided by 10,208 will give us 17.6 miles per hour. All right, so that was a little bit more complicated. Just remember, our units are super important because that will tell us what we need to multiply by for our conversion factor. Okay, so now we've got some definitions, just like a vocabulary page. We're going to go over some of them. So a ratio, it compares two numbers by division, can be written as A over B, A to B, or A colon B, where B does not equal 0. So the denominator is not going to be 0. I would just write the big thing here is that we recognize that ratios are the same as fractions. Okay? A rate. A rate is a ratio with two quantities with different units. So just like we did before, that would be miles per hour. Okay? There are two different units in the numerator and the denominator. Okay? Another example would be feet per second. And you can probably come up with a bunch more. A unit rate. A unit rate is a rate with a denominator of 1. Okay, so notice how it's 7 miles for 1 hour and $6.50 for one ticket. Okay, whenever the denominator of the rate is 1 unit, that is considered a unit rate. Okay, so word or phrase, conversion factor. So a conversion factor, we just talked about these. They help you change a value in one measurement unit to a value in a different measurement unit. Conversion factor is a ratio of two equivalent measures in different units. An example of that could be, just like we did before, seconds over hours. And that would be, excuse me. Let me rewrite that. It's 3,600 seconds per hour, or 12 inches per foot, so on and so forth. Okay, it's a conversion factor. All right, next we've got a numerator. Oh, and for a conversion factor, right down below, always equal to 1. The numerator is just the top number in a fraction. So for 24 over 39, the numerator is the 24. The bottom number in a fraction is the denominator. That would be 24 over 39. That would be the 39. Okay? Whoops. All right, we've got some practice for you guys. So which is the better buy? 6 bagels for $3.29. or 8 bagels for $4.15. Well, in order to figure this out, we need to take the price divided by the number of bagels, because we want to find out what's the price per bagel and then compare them. So price per bagel. All right, so let's take the first one, which we have $3.29 per 6 bagels. And our unit on the top is dollars, so let's make sure that we put a dollar sign. This will then become, once we divide both the top and the bottom by 6, we're going to get our unit rate, which will be per bagel. 1 bagel on the bottom, and 3.29 divided by 6. That will give us approximately 55 cents per bagel. And that's an approximate because we rounded. Okay, and then the second one, we've got $4.15 for 8 bagels. Let's figure out what's the cost per bagel. So 8 bagels for $4.15. So let's take the price per bagel. That would be $4.15 for 8 bagels. So once we do that, we've got to divide both the numerator and the denominator by 8 so that we can get our unit rate. Once we divide by 8, we get just bagels on the bottom for 1 bagel. And we're going to get $4.15 divided by 8 on the top. And doing that on the top, we are left with 52 cents. Obviously, the second one is cheaper, so it is a better deal to go with 8 bagels for $4.15. All right. So what is 7 pounds and 4 ounces converted to ounces? So we have that 4 ounces, which is already in ounces. So we need to figure out what 7 pounds is compared to in ounces. All right, so let's take this whole thing and we're gonna bring it out over here. All right, so 7 pounds, 4 ounces. Let's get started. Plus 4 ounces. We want this to convert into ounces. So in order to get this into ounces, we have to take 7 pounds. Now, there are 16 ounces in every pound. So what we're going to multiply by is 16 ounces per 1 pound. Now look, our pounds are going to cancel, which is awesome. So all we're going to be left with is our ounces. And ounces, 7 times 16 will give us 84. So we've got 80, I'm sorry, that's not accurate. 7 times 16 is actually going to give us 112. So it's 112 ounces in total. So we've got 112 ounces. Remember, we have to add that back with the 4 ounces we had to start with. So we're going to rewrite this as 112 ounces plus the 4 to begin with, and that will give us 116 ounces in total. So that 7 pounds and 4 ounces converts to 116 ounces. All right, let's take a look at number 3. So which is longer, 12 meters or 13 yards? So we have to, whenever it gives us 2 units that are different, we have to change one or the other into the other unit, okay? So our conversion factor for this one is that 1 meter is equivalent to 1.1 yards, okay? So if that's the case, let's go ahead and change that 12 meters into yards and figure out if it's more or less than 13. So our conversion factor is going to be 1.1 yards over 1 meter. And we're going to change that 12 meters into yards. So once we multiply, we cancel out the meters, and we're left with 12 times 1.1 yards, and that will give us 13.2 yards. So 12 meters is larger because 13.2 yards is longer than 13 yards. All right, let's finish up with number 4. Number 4, a car is traveling at 55 miles per hour. What is the car's speed in feet per second? So this is one of the tricky ones where you see how we're converting miles to feet, and also we're converting hours to seconds. So let's set it all up. We've got 55 miles per hour. So the first thing we need to multiply, let's get rid of the miles. So we're going to put miles on the bottom, and we want to convert that to feet on the top, okay? And then we're going to multiply again by another conversion factor, and that conversion factor is going to get rid of hours. So hours on the top, and we're replacing it with seconds. So seconds on the bottom. Now we've already done one similar to this. Remember, it's 3,600 seconds in 1 hour. And how many feet are in a mile? There are 5,280 feet in 1 mile. 5,280 feet in 1 mile. So now let's do the fun part. Let's cancel everything out. And you always can check your work by canceling out to see if you're left with only 1 unit in the denominator and only 1 unit in the numerator. So the miles that we started with are going to cancel with these miles, and I see hours on the top and hours on the bottom, which will cancel, okay? Remember, you can only cancel if they are in the top and the bottom. So you see, notice how the miles appeared both once in the top, once in the bottom, and so did the hours. That's the only way we can cancel them. Okay, moving on. So now we've got 55 is getting multiplied by 5,280, and that's feet on the top. And on the bottom, we've got 3,600 because it was just 1 hour per hour and per mile. So it was 1 and 1 and then 3,600, and that was seconds. So this is going to be equal to 55 times 5,280. That gives us 290,400 over 3,600 feet per second, which is going to give us 80.7 feet per second, roughly. Feet per second. And if it doesn't ask what to round to, guys, go ahead and just round to the nearest tenth, like I did. So that's 7. All right. Our exit ticket. So could multiplying by a conversion factor change the actual amount? Why or why not? No, it will not. And why? Because conversion factors only change the units. They do not, or they don't affect the actual value. All right. And there's your homework. Good luck.